Okay, let's look at curve fitting with polynomial functions again and talking more about real-world data. Often real-world data can be quite irregular, and using finite differences to find a polynomial function is going to be pretty hard. So we're going to use the regression feature on your calculator. Remember, the closer the r squared, oh goodness, sorry, closer the r squared value is to 1, the better the function fits the data. The table shows the opening value of a stock index on the first day of trading in various years. Use a polynomial model to estimate the value on the first day of trading in year 2000. So what we need to do here is use our regression functions and come up with an equation and then evaluate that equation for year 2000. And again, we're going to do list 1, list 2, but our year cannot be 1994. We have year 0, 1, 2, 3, 4, 5, and then when we evaluate it for year 2000, we're going to evaluate it for 6. Okay, so after you plug in list 1 and list 2, you're going to, what I always do, first I'll do a linear regression, and I'll write down the r squared value. Then I'll do a quadratic regression, and I'll write down the r squared value. Okay, you get the idea? Then I'll do a cubic regression, and I'll write down the r squared value. I'll do a quartic, and I'll write down the r squared value. Okay, it's not linear, it's not quadratic. Our cubic r squared value is 0.5833, and our quartic is 0.8921. Okay, it's not the greatest data, but quartic is pretty darn close. So once we do our quartic regression, we get, you're going to do the same steps as the last one, and we get an equation like this. F of x equals a minus b, I'm just looking at my calculator right now, plus c minus d plus e. You're going to have to arrow down the window of your calculator to see all these. And when I'm doing my homework, I write down all of the r squared values that I got so that I can defend myself. This is the best one. That didn't work. And when you see these, those don't work either. So I write them down just to sort of defend myself. Next thing we're going to do is evaluate that function at 200. You can either type in 200 and do all of your multiplication. You can do synthetic substitution at this point because you know how to do that, and that would be pretty simple. Or you can plug this equation into y equals in your graphing calculator and look at x is 200. All of those are going to be the same, and I am really sorry we cannot do x is 200. We just talked about that. We want to evaluate it at 6. So you're going to plug in 6, and our answer, do a little number crunching, is 2,563.18. And we're all going to get slightly different numbers for that, but they'll be pretty close. And as long as you show all your work here, your work will be defended. Okay, I just put an extra slide, sorry. All right, you try this one on your own, and it's our last problem of the day. Okay, I did linear regression on L1 and L2, and please look, L1. Don't just willy-nilly start assigning values to the years, because these years skip around a little bit. Our first year is 1994, 1995, 1996, 7, 8, 9, 2000, 2001, 2002, 2003, 2004. And it wants to evaluate at 1999. 1999 will be year 5. Quartic fit best. And again, I'm showing all my work to sort of defend what I'm doing. Then I do the quartic regression, and I get my function. Then I evaluate that function at 5, which is 1999. And that's all we have for today. Good work.